What I want to do now is let's try and find A inverse for the matrix A, just being a generic A, B, C, D. And if we can have a formula for the inverse of a 2 by 2 matrix, that'll be really helpful for us. And what we're going to do is the same process that we did before. I'm going to take our matrix A, we're going to augment it with the identity. One, zero, zero, one. And we're going to augment it with the identity and try and get the left side to be the matrix, the identity 1, 0, 0, 1. And then whatever the right side is, that'll be our inverse. This is going to get a little bit algebraic. Okay, this is going to be a calculation, which is fine. I want to get used to doing these calculations. They're not hard. It's a little bit of bookkeeping. It's nothing more. I'm going to assume that A, B, C, and D are non-zero, although in general, you don't have to. It's just special cases. If A is 0, then what you could do if that was a 0 is you could then switch the 2 rows of A and then do this again. And it turns out if A and C are 0, then there's no inverse. There's no way that you can add a multiple of one row to another to get a 1 to appear there. It's just not going to happen. So just to make this a little easier, I'm going to assume that A is non-zero. And let's see. So what we're going to do here is let's multiply row 1 by 1 over A. And that'll give us a 1 to use there as our pivot. So we have 1 B over A, 1 over A, 0 over A, otherwise known as 0. The second row we haven't messed with, so just one step at a time here. Next, we're going to look at the second row, and let's see, we're going to replace row 2 with row 2 minus C, row 1. And if we do that, row 1's going to stay the same. Row 2 is going to be, help me out here, negative C plus C is 0. Of course, that's by design. Negative BC over A plus D. So this is D minus BC over A. 0 minus C over A. And let's see, this is 1. 0 plus 1 is still 1. Okay. And the second equation, I don't like that half of it is in a fraction and half of it's not. Fractions are unavoidable, so let's make it an entire term as a fraction. So I'm actually going to just make that AD over A. And so here we have AD minus BC over A. And what we're going to do is I'm going to multiply by the reciprocal of that so that we can get a 1 there. So R2 is going to be A over AD minus BC. And so what's going to happen is we're going to get 1 B over A, 1 over A, and 0. And this is going to be 0, 1. Now, if I multiply negative C over A by A over AD minus BC, we'll get negative C over AD minus BC. And 1 times that will be A over AD minus BC. Okay. And now we're almost ready. We're almost done. I mean, we have just one more term to take care of. That's the B over A term. So we're going to take row 1 and replace it with row 1 minus B over A row 2, which will be what it is. So here we go. We have 1, 0, 0, 1. That part's easy. Okay, so 1, 0, 0, 1. Let's make a little room here. So we have 1, 0, 0, 1. And then on the right, The second row is going to stay the same. We got negative c over this quantity AD minus BC, A over AD minus BC. And let's see, if we multiply by negative B over A, let's do the easy one first. So if we take A over AD minus BC, multiply by negative B over A, we're going to end up with negative B over that same quantity, AD minus BC. And then all we have left to do is the bottom one. So if we take negative B over A, let's do this separately to the side here. We're going to take 1 over A and subtract B over A times negative A over AD minus BC. So this just off to the side, I'm just doing this work to the side here. This is going to be what it is. It's going to be 1 over A plus B over AV minus BC. And there's nothing really nice about that. Oh, good, I made a mistake. I'm glad I made a mistake because this is ugly and it's not supposed to be so ugly. This should be a minus C. I just didn't copy that right. I don't want these to cancel. So this is going to be good. Let me take one step back. Sorry about that. So this is going to be 1 over A plus BC over A times AD minus BC. And then let's get a common denominator. So that'll be AD minus BC all times A. So this is AD minus BC all over our common denominator A times AD minus BC. And I forgot the BC over here. So this is, just to break this down one more time, this is our 1 over A plus BC over A times AD minus BC. And the BC is going to cancel. That leaves us with AD over A times that quantity. The A's are going to cancel. And so altogether we'll end up with D over AD minus BC. Okay. So the moral of the story here is that if A is the matrix A, B, C, D, then A inverse is going to end up being the matrix D over AD minus BC minus B over AD minus BC minus C over AD minus BC and A over AD minus BC. And you can factor out, if you like, the 1 over AD minus BC. And you're left with D, negative B, negative C, A. This quantity AD minus BC is going to come up again and again and again and again in unreasonable amount of time. So it's got a name. It turns out that if A is the matrix A, B, C, D, then this quantity AD minus BC is called the determinant of A. Chapter 3 is all about determinants and all the things that the determinant tells you. It actually tells you an incredible amount of information about A, and it tells you a lot about many, many things. There was a guy in the 1800s, a mathematician in the 1800s, who ended up writing a 4-volume book series about everything that the determinant tells you. It's just a ridiculous amount of information that's encoded in that quantity AD minus BC. Sorry, my alarm went off there. So it's, the determinant tells you an incredible amount of information there about the matrix A being ABCD. Let's do this one more time. We'll edit. In the determinant, there's a mathematician, try 2. There was a mathematician in the 1800s who wrote a 4-book series, a 4-volume series about everything the determinant tells you and all the different linear algebra problems. that you can study. It's just an incredible amount of information that's going to be encapsulated or kind of encoded in the determinant AD minus BC. So we'll get into all that, and we'll do some of that in chapter 3. One last thing I just want to address. This is what A inverse is. When does A inverse not exist? Well, it turns out that A inverse does not exist. We have a formula for it. So as long as everything here makes sense, as long as our matrix A allows this quantity to make sense, then we have an inverse. So it turns out A inverse does not exist if and only if AD minus BC is 0. So AD minus BC is the determinant. If the determinant is 0, then there's no inverse. That's like when you had the solution, or when you had no solutions to the equation 0x equals 1. It just turns out that 0 doesn't have a multiplicative inverse. And so the matrices that don't have multiplicative inverses are precisely the ones where the determinant is 0. The if and only if statement means there's two things going on. If A inverse doesn't have, if A doesn't have an inverse, then the determinant is 0. And if the determinant is 0, A doesn't have an inverse. So knowing one of those tells you about the other. So that's the if and only if part, is that it gives you both directions. A inverse not existing implies that the determinant is 0. If the determinant is 0, that tells you that the inverse doesn't exist. Okay.